Hello. Okay. So today I will actually upsolve the problems from the last weekly contest of 466. Okay. So if you have any doubt, any other approach is in your mind, you can actually comment on that. We will discuss that. Okay. So let's start from the first problem, that is minimum operations to equalize array. So what is the problem statement? Problem is that you are given an integer array nums of length n. Okay, in one operation choose any subarray nums of L to R and replace each element in that subarray with the bitwise AND of all elements. So we have to return the minimum number of operations required to make all elements of nums equal. Right? A subarray is contiguous non-empty sequence of elements within the array. So something like 1, 2. Let's see the first example. So the first example is 1, 2. Now what is your target? Target is to convert all the numbers to equal. Suppose I'll convert this to x. So all the numbers should be x. Okay. Now what is the operation I can do? So I can choose one subarray. So this is the subarray L to R, and first of all calculate the AND of all these numbers. Suppose actually x1, x2, x3, x4, in this actually suppose xn. N numbers actually present in the subarray, in this subarray. Now first of all I will actually calculate the AND bitwise AND of all these numbers. x1 AND of x2 and AND of x3 then x4 in this way. Right? Now suppose I got actually here actually y. Okay, this output actually is y. Now all the numbers within this range L to R will be changed to Y. So it will be replaced with Y. Correct? Now how can actually, so this actually the operation I can do. Now our target is to convert all the numbers to equal. So for this example 1, so our in array is 1 and 2. So here actually we know that we have to do some operation, because here actually you can see that two numbers are distinct. One is 1, another is 2. Right? So I have to do the operation, right? So suppose I will choose this subarray 1 and 2. 1 and 2. So first of all calculate the AND bitwise AND of all these subarray numbers within this subarray. That means 1 and 2. Right? So it will be, if I represent this with as binary, so it will be 0 1, 2 will be represented as 1 0. So if I do the AND of this, so it will be 1 and 0, it will be 0, and 0 and 1, it will be again 0. So ultimately it will be 0. So all the numbers here it will be replaced with 0, 0 comma 0. So how many operation I have done here? 1. So you can just see there that after one operation I can actually convert all the numbers to equal 0 comma 0. Right? So actually our answer will be, expected output will be 1. Let's see here. Yes, expected output is 1. Now if all the numbers is already equal, that means in the example 2 you can see that all the numbers will be 5 5 5. So this is already there, is all numbers are equal, so we don't need to do any operation, so our answer will be 0. Now suppose we actually another array that actually 1 2 3. Now you can see that actually you have three numbers, three distinct numbers. Right? Now we have to calculate the minimum number of operation I have to do. So for that, what actually I can do, I will choose one subarray, then actually convert the subarray with the replace with all the numbers within this subarray with the AND-wise bitwise AND of value. Right? Suppose I will choose, suppose first of all this subarray. So first of all calculate the bitwise AND of all this number within this subarray. So this will be again 0. So after this operation, after this one operation, our array will look like 0, 0 and 3. Right? Still we have some one element 3 that is actually different from other elements, that means 0. So we have to do some operation. So suppose I will choose this array now. Suppose this array I will choose now. Okay. So first of all, calculate the bitwise and 0 and 3. It will be again 0. So all the numbers within this array will be replaced with 0. So this will be one more operation. So our array will look like 0, 0, 0. So in this approach, in these steps, how many operation actually I have done? That actually plus one operation here, one operation here. So answer will be 2. Correct? Now our target is it possible to convert with 1 or not? Right? So how will we check that? So we can do that. How? Suppose we actually have array 1, 2, 3. Right? This was the array, input array. Now first of all, if I choose this whole array as a sub-array, like if I apply the operation on the whole array at a time. So first of all, calculate the bitwise AND. So 1 and 2 it will be 0, 0 and 3 it will be 0. Right? This is clear. So ultimately you can see that 1 and 2 and 3 ultimately bitwise AND value is 0. Correct? So all the numbers in one operation will you convert to 0, 0, 0, all the actually 0. So you can just hear that actually how many operation we need here? Only one operation. So that's why our answer will be actually 1. In the previous approach, we have to use two operations, two times, right? Here actually one operation, another actually operation here, right? But we can actually optimize this by using one operation. Okay, this is better than the previous approach. So is it possible to convert all the numbers with 0 operation? Not possible, because all the numbers are different. So we have to do some operation, right? So that's why here actually you can see that our answer will be 1, right? So you can just notice here that observe the pattern actually. So if all the numbers in the input are actually equal, x comma x comma x, so that time actually our how many operation need 0, because all the numbers are already equal. But if there is any different or distinct number actually present, suppose x, y, z, a, b, c in this way, that time I can actually convert all the numbers equal by using one operation only, right? Because I will choose the whole array as a sub-array, and I will apply the operation here. I will do the operation on this sub-array as a sub-array. But so for that actually I need actually one operation only. So that's why our expected out will be either 0 or it will be 1. Clear? When it will be 0, when actually our input array, all the elements in the input array is equal, and when it will be 1, when actually we have some element that is different, right? At least two distinct elements. So that time our answer will be 1. Got it? So understood, right? Now let's see the code. Okay, before that, let's check the voice and audio is clear or not. Okay, so now go to the code. So to identify that how many distinct element is present, so that we can actually use set that for that if the set actually store, you all know that set will store the unique elements, right? So like if I actually store 1 comma 1 in the set, so it will store only 1. But if I actually insert 1 comma 2, like first I will store 1, then actually if I try to store 2, so it will actually create two elements, 1 and 2, right? So it will store only the unique element, unique number. So to identify that all the numbers is equal or not, so we can actually use set here. So set initially this integer type, okay, and I will iterate the input array. So ultimately I will actually just blindly store into the set whatever the number actually I have in the input array nums. So after that I can actually, we all know now that our answer will be either 0 or it will be 1. So when it will be 0, so all the numbers are already equal. So suppose our input array is 1 comma 1 comma 1. So that time if I store this into set, so we know that it will store only 1 1, correct? So that time I can actually check that if set size, whatever the set actually is present, is equal to 1, that means all the numbers are all equal, right? If it is greater than 1, that means we have at least two numbers that is different. So that time we have to do the operation. So that time our answer will be 1. So that's why from the set size we can actually identify that or actually equal or not. So if a set size equal to 1, that means all the number actually is equal. So that time return 0. Else we have some element, at least two distinct elements. So that time return 1. Got it? So if you have any doubt, you will comment on that. And before going to the next problem, I will try to answer that. Okay, so go to the next problem. Is it not working? Leetcode. Okay. So this is the next problem, new operations to transform string. So the problem statement is that you are given a string s. So you can perform the following operation any number of times, including 0. So any number of times, choose any character C in the string and replace every occurrence of C with the next lowercase letter in the English alphabet. So return the minimum number of operations required to transform S into a string consisting of only A characters. Okay. So that means, so we actually have some string. Let's see the first example, YZ. YZ. So in one operation, what actually I can do? I can actually and we'll take one character. That means suppose I have choose Y. So there is one more Y. So they mentioned that in one operation you can choose any character. Suppose I actually for this operation I have chosen this Y. Now all the Y, all the character present as Y in the input string, so all will be converted to the next character. What will be the next character? Y plus 1. So it will be Z. So this means clockwise. That means A will be converted to B, B will be converted to C, C will be converted to D. So initially Y will be converted to Z, Z will be converted to A. Got it? This is the means cycle. Right clockwise, right? So now, so actually I have chosen suppose Y. So after this operation, what will be our input array will look like? This will be Y will be converted to Z, Z is already Z, and Y will be converted to again Z, right? So all will be now ZZ. So this is after one operation. Next is, but our target is to convert all the characters to A, right? We will stop when all the characters actually is A. Now, next, for the next operation, suppose I have chosen Z as the character. So now all the character present as Z in the input string or in the string, all will be converted to the next character. So what is the next? Z for the A. For the Z, it is A. So all the character will be converted to A now, right? So here actually one more operation I can do. So total how many operation I have done? 2 operation, right? Our target is to minimize this number of operation. This is our target. So now you can think that how can we observe the pattern actually. Suppose actually we have y z. Okay. Now suppose first of all I have chosen z as our character to do the operation. Okay. So that means all the z will be replaced with the next character. So for the z, the next character is a, right? So actually z is present here. So the our in string will look like y a, correct? Y a. Now actually I have done one operation. Next is still actually have some character that actually not a, because our target is to convert all the character to a. Okay. Next, suppose for the operation I have chosen y as our character to do the operation. So for the y, the next character it will be z. So all the y will be replaced with the next character. That means z a, right? Actually again I have done one operation. Now still actually we have some character that is not a, that is z. So that means again we have to do the operation. So suppose I have chosen z as our character to do the operation. So for the z, the next character it will be a, correct? So all the z will be replaced with a. Now it will be a. So here actually I have done one more operation. So that means how many total operation actually I have done? Here actually one, here actually second time, here actually third time. So total 3 operations, right? So next our target is to optimize the number of operations, right? Because anyway I have to convert all the character to a, but our target is to minimize the number of operations. So if I choose first convert the y to z, instead of z, if I choose y first, that convert all the y to z, so that time what will happen? So y z, so after one operation, so all the y will be replaced with z, so z, correct? Next one more operation on z, so z will be replaced with the next character as a, so all the character will be now a. Clear? Actually how many operations I have done? I have done 2 operations, correct? So this is better than the previous approach. There actually I have done 3 operations, actually I have done 2 operations. Clear? So you can observe one thing. A will be, if I actually do the cyclic operation, so A will be replaced with the next character as B. If I do the operation on B, it will be converted to C. C will be converted to D in this way, right? So if actually some character as suppose C, anyway our target is to convert this C to A. So first of all, if I convert this C to D, then D to E, then E, in this way I will convert this Z, then A, right? Because this is cyclic wise. Now if I do some, suppose actually I want more character of D, C and D. Now if I first convert the D to A, means CA. So there actually suppose I actually need X number of times I have to do the operation. Next, if I convert this C to A, then suppose again actually we need actually suppose Y number of operation I have to do. So this will be now AA. So total how many operation I have to do? X plus Y. X is the number of operation to convert this D to A, and Y is the number of operation I have to do to convert this C to A. Clear? And total how many operation I have to do? X plus Y. But if I convert this CD to DD first, then actually convert this AA, so it will be only, suppose actually I know that for D, convert this D to A, if I know that X number of times I have to do the operation, so here actually one more time, that will be X plus 1, total X plus 1 number times I have to do. If I should convert this C plus first to D, then convert all the D to A, because I know that to convert this from D to A, I actually have to do X number of times operation. So that's why it is always better. So X plus 1 is always less than equal to X plus Y, because Y can be greater than equals to 1, right? So that's why our target is to do this. So first of all, whatever smallest character I have, first of all convert this to A, because anyway that we have to do the convert this character to the A, because ultimately we know that C have C, whatever the character is present as C, that will be anyway converted to A. So in between whatever the character will be present, that will be anyway converted together. Like here actually you can see that I know that for C to actually A, I have to do one Y operation, Y number of operation. So if I actually convert this C to first D, then anyway all the characters present in between, that will be also converted to actually A together, because I can actually replace all the character, same character together, right? So that's why what are the smallest characters I have? Smallest character. That try to convert this to A. Correct? So if I identify that what is the smallest character actually present in input string except A, because A is our target. If all the character is already A, so that means there is no, we do not need to do any operation, right? So that's why except A, whatever the next smallest character I have, it can be B, it can be C, right? So that's why I will identify that what is the smallest character present. So that first of all I will convert this to A. So in between whatever the character is, different character is present, because in the example you can see that we actually have C, D. So if I convert this C to A, so in between D will be also convert to A in between, because it will be first C will be converted to D, then 2D will be converted to anywhere together with A. Clear? So that's why we have to identify what is the smallest character. You got the logic, right? What is the smallest character? We have to identify that. Then we have to check that all the character in between, whatever the different characters present, that will be anyway converted to A. Got it? So that's why. Now let's see the actual code. So if you have any doubt, it will comment on that now. So suppose we actually taken another variable to identify what is the smallest character except A. So this is suppose mean char. So initialize with A. You can actually initialize with any value. Now I will actually iterate the input string. Okay. So what is our target? Target is to identify the meaning of smallest character except A. So I will check that if our current character, whatever actually I am iterating the input string. So if it is not equal to A, that means this is one possible smallest character possible maybe. So I'll check that if our still smallest character or the mean char, it is still A. That means this is the first time I am seeing in a character that is except B, except A. Sorry. So that will be actually I didn't just directly modify the mean char variable with the what are the current characters I have. It may be B. So for this example, I am iterating from left to right. So first of all, our mean char it will be A, and I am first character actually I am saying that is actually Y. So our mean char is still A. So now I know that this is the first character that I have seen, which is not A. So I'll just modify the mean char with Y. Now mean char it will actually point to Y. Got it? Now go to the next character. Next character is Z. Okay. So for Z, I know that okay, this is not A. So this means this character I have to convert this to A, because our target is to convert all the numbers, all the character to A. So that's why I'll check that this is the first time I'm seeing any character that is not A. Okay, this is not equal to A because mean char already replaced with Y. So okay, it will come to this else part. So in the else part, I will check that this is minimum or not. So previously I have till now what are the minimum characters I have, that is actually Y, and current character it is actually Z. So that means I will compare with Y and Z. Okay, Y is the smallest, so again I actually store this smallest character as Y. Okay. Now after this for loop, in this mean char variable, I can actually easily identify that what is actually the smallest character I have except A. Now our target is what? I have to identify the minimum number of operations, right? So if our minimum character is still A, that means all the character is still already equal to A. Then actually it will not come to this part. This part line number 7. It will not come to this. This line number 6 will be always false. Correct? Line number 6. If our minimum character after this for loop, if I see that minimum character variable is still A, that means this line number 6 is always false. Like current character is not equal to A. That's why it will actually go to the inside to this if block, but it will not come to this. So that means this will be always false. So if it is minimum character is still A, so I'll return 0. Means I don't need to do any operation here because all characters are already equal. Correct? Else part I have to identify that what is this, I know after this for loop what is the smallest character except A present in the input string, and I know our target is to convert this to A. Right? So how many operation I have to do to identify that? Suppose I got a smallest character as B, and I know that I have to convert this to A. So if I actually present this as a on an array, so what will actually present? So A will be converted. A will be first placed as index 0. Next B will be in index 1. C will be at index 2. So in this way Z will be placed at index 25. Correct. So if it's a circular wise, that means after Z I will get A. So what is the index for that? That actually 26. Correct. So that means how many operation I have to do? First convert this B to C, then C to D, because I got a small character as B. So C to D. So actually you can see that ultimately what is the position of A? A position is whatever the current position 0. Suppose this will be base A plus 26. This will be the next A position of the next A character A plus 26. Correct. So this is the position of next A. So how much operation I have to do? Just subtract with whatever smallest character I have. Actually it is actually B. So subtract with B. So here actually on the array actually I can easily identify that how many operation I have to do, right? So that's why just subtract with A plus 26 to know the next position of the character A, and subtract with the current smallest character which I have in the input stream. So that will be minus the whatever the smallest character. Got it? So you have any doubt, you will comment on that before going to the next problem. Okay, so now go to the next problem. Count bool subarrays. So what is actually bool? You are given an integer array nums with distinct elements. A subarray nums of L to R of nums is called a bool if the subarray has length at least 3. Okay, that is R minus L plus 1 greater than equals to 3. Okay, the minimum of its two ends is strictly greater than the maximum of all elements in between. Okay, return the number of bool subarrays in nums. So that means first of all we have to identify that how many bool actually I can create. So what is the condition for that? Suppose we actually have one subarray 1, 2, 3, 4. Okay, so this actually the length is how much length? Length is 4. Okay, length is greater than equals to 3. So this may be one first condition is that length should be greater than equals to 3. Now what is I want to identify? I have to identify that what is the edge character actually present, edge element, that actually 1 and 4. So what is the minimum of that? Minimum of this is actually is 1. So this should be greater than the minimum of all the elements present in between. So that means 2 and 3, right? 2 and 3 is present in between. So what is the maximum of that? 2 and 3, that is actually 3. So each one is greater than 3? No. So this is not a bool. But suppose let's see another array or subarray 4, 1, 2, 5. This is suppose I am just saying validating that this is actually one possible bool or not. So what is the edge? Edge is 4 and 5. So for the edge I have to check I have to take the minimum value. So minimum will be 4. Now for the number present in between, that actually I have to take the max of that. So which number is present in between 1 and 2? So what is the max? Max value is 2. So is 4 greater than 2? Yes. So this is one possible bool. Correct? Now what is the brute force approach you can think? So for this example, suppose 2, 5, 3, 1, 4. 2, 5, 3, 1, 4. So any way to check that how many actually subarray actually I can actually create a bool, right? So first of all generate all possible subarrays. So what will happen? 2, 25, 253, 2531, 2531, 4. Right. Next is 5, 53, 531, 5314. Next is 3, then 31, 314. Right. In this I will generate all the possible salary. Next is 4. Now I know that this is all possible salaries, right, from this input array. Now I will check that this. I will try to check that each salary, that is it can actually create a ball or not, right? So first of all, what is the length? I have to identify the length, and the max of the two edge. Max of the edge should be greater than the minimum of all the numbers present in between. So length is already less than equal to 3, so it will not actually create a ball. Next is still length is it will not satisfy the first condition, length, so it can't create a ball. Next is 253. Okay, length is less than greater than equal to 3, so it can actually create ball, maybe. So how will you check that? So I'll check that what is the age. Age is 2 and 3. So what is the max of that? Sorry, mean of that? That is 2. And in between which number will present? Only one number. So that is 5. So 2 is greater than 5? No. So this is not a, it can't actually create a ball. Next is 2531. So ball actually is something like this, right? So that means all the number present in between, that should be less than this 2 age. So that's why actually for this array 2531, what is the age? Age is 2 and 1. So what is the minimum? Minimum is 1. So in between which number actually present as maximum? That actually 5. So 1 is greater than 5? No. So it can't actually create a ball. Next is 25314. 25314. So what is the age? Age points are actually 2 and 4. So what is the minimum of that? Minimum is 2. Okay. So in between which number actually present as a maximum? Maximum number actually present as 5. So is 2 greater than 5? No. So it can't actually create a ball. Correct? Next is similarly this length is less than 3, so it can't actually create a ball. Here also the length will not satisfying. Next is this length is greater than equal to 3, so it can actually create. Alright. So what is actually the age points? Age points is 5 and 1. So what is the minimum of that? Minimum is 1. And what is the number is present in between? That is 3. 1 is greater than 3? No. So it can't actually create a ball. Next is 5314. So 5314, what is the age points? Age points is 5 and 4. So what is the minimum of that? Minimum is 4. And which number is present in between 3 and 1? So what is the maximum of that? Maximum is 3. Right. So is 4 greater than 3? Yes. So it is one possible ball, right? Correct. Next is this survey 3. Okay, length is less than 3, so it can't actually create. Less than 3, it can't create. Next is 314. Okay, so what are the age points? Age points are 3 and 4. 3 and 4. What is the minimum of that? Minimum is 3. And which number is present in between? That is only 1. Okay, only 1. So max will be 1. Now, is 3 greater than 1? Yes. So it actually creatable. So this is one possible answer. Right? Next average is 4. So length is less than 3, so it can't actually create a ball. So how many actually valid average I can valid ball actually I can create? This is one possible 5314 and another is 314. Right? So you can actually use this approach also. So what is time study for this approach? So first of all we have to generate all average. Correct? Generate all possible average. First step. So what is time velocity to generate all possible average? So suppose actually have x1, x2, x3, x4, 4 elements in the input array. So using this x1, how many average I can generate? x1, x2, x1, x2, x3. So initially I can actually generate 4 different averages, right? Using x1. Similarly, with x2 I can generate 3 different averages, right? Similarly for x3 I can generate 2 different averages, and for x4 I can generate only one average. So you can see that for the first number x1, I can generate 4 different surveys. Next actually I can generate 3 surveys. Next is I can generate 2. Next is 1. So you can see that this actually ultimately, if actually assume that the input array length is n, so how many total surveys I can generate? For the first character, I can generate n different subarrays. Next, I can generate n minus 1. Next, n minus 2. In this it will continue until 1. So our total subarrays will be sum of this. So total it will be the sum of 1 to n. So this will be n into n plus 1 by 2. Right? This is the total number of subarrays I can generate. So roughly it will be big of n square. Alright. So you can see that to triangular city it will be big of n square. So here actually n length is, you can see that 10 to the 5 constants. In the constants you can see that the n, the number of input array length is 10 to the 5. So 10 to the 5 the whole square. So it will be actually 10 to the power 10. N square it will be 10 to the power 10. Right? So it will actually give us 10. Right? So we have to think about the more optimized approach. Right? So how can I actually optimize this? So you can just see actually draw the condition of ball. So we actually have some ball. Okay. Now they mention that whatever the number is present in between, okay, that should be actually less than the number present in the left side and right side both. Like suppose actually x1, I actually have x2, and all the numbers, suppose y1, y2, y3. So that all should be actually less than all numbers present in this. That should be actually less than minimum of x1, x2, right? So ultimately what we are trying to find that. We have to find out that is there any number present in the left side and the right side, both sides, which is actually greater than the current number. So in the left side also we have some number that is the current number. Alright? And right side also we have to identify the similar way. And right side also we actually have some element which is greater than the current number. Then actually it will be part of the one bool, correct? So these two conditions should be satisfied, right? One is the left side also, which actually index I have. Currently I actually suppose ith index. So if it is part of, if it can actually create a bool, so it should actually have some element in the left side and the right side which actually greater than the current number. Then actually it can actually create a bool, right? So that's why these two conditions should be satisfied, right? Left side, in the left side also we have to identify that is there any number present in the left side which is greater than the current number, right? So for this approach, for this logic, what actually the data structure you can think about, that will be actually monotonic stack, because by using monotonic stack we can easily identify that what is actually the next data elements, right? From the left side also we can actually do that, and from the right side also we can do that. If actually iterate from left to right, I can actually easily identify that is there any in the left side is there any number which is greater than the current number, and in the if I do the right to left, then also I can identify that is there any number in the right side of this current index which is greater than the current number, right? So it will be something like left to right, and this will be right to left. So monotonic stack you all know. So monotonic stack means it will just store in the non-decreasing or non-increasing. You can store any way, whatever actually the requirement. So for this example, suppose for this example 25314, 25314. Now for each index I want to know that what is the target. Target that in each any index I can actually say that I have to say that is there any number present in the left side or in the right side which is greater than the current number, right? True or false, not like which number, what is the number value. We don't need to know that. So we have to know that is there a number present in the left side or right side or not, right? So suppose first of all I want to know the left side. So how many numbers is present? 1 2 3 4 5. So suppose actually I have initialized with -1. Okay. Now monotonic stack, that means I have to use one stack. So now actually I have iterating from left to right. First of all it is actually index 0 2. Okay, so 2. So is there a number present in the left side? No, because the stack is still empty. Okay, so that means it will be still 1. So before going to the next number, I have to store the current index as 0. Okay. Now go to the next index 1. So that actually 5. So what is the stack is empty? No. So we have some element in the left side. So I have to check that what are the numbers present in this current index 0 means 2. Index 0, the value is 2. So 2 is greater than 5? No. So it will be popped. It will be popped. Okay. So next is our stack is empty. Now if the stack is empty, that means there is no number in the left side which is greater than the current number. So you can see that in the visualize from the test case also, is there any number in the left side which is greater than 5? No. So it will still -1. Next, before going to the next number, I will store this index as 1. Now come to next index as this index 2. So 3. So current value is 3. And what is the top value? Top value or the stack top value is 1. Sorry, index is 1, value is 5. So 5 is greater than 3. Yes, I have to stop here because this is one possible answer. So I will actually check, okay, stack is not empty, and whatever the index value is 1. So I'll just override this with 1. That means you can just identify that for the index 3 or index 2, what is the next in the left side, what is the index or which number actually is greater than the current number. You can see that in the index 1, I actually have 5 which is greater than the current number. Got it? Clear? So next is, before going to the next number, I will store this index as 2. Okay. So 2 means, so now go to the next number as index 0, 1, 2, 3, and the value at the top as the present as index is 2. So what is the value for that index 2? That actually is nums2, index value is 3. So the number actually is 3. So 3 is greater than the current number? Yes. So I'll stop here because this is one possible answer. So I will just store this as, what is the index? It will be now 2. Clear? Next, before going to the next number, I'll store this index 3. Just actually observe the stack. When actually I am just popping from the stuff, and when actually I am storing this into the stack. So before going to the next number, I will store that. And when actually I am current index, so I'll check that which number actually, we have to identify that which index is greater than the current number. So I will pop till actually will not get any number which is greater than the current number. So now next to the next number is 4. Okay. Next number is 4. So what is the top index is 3. So index 3, what is the value? Value is 1. Okay. So 1 is greater than the 4? No. So that time actually I will pop this from the stack. So I'll pop this from the stack. Just observe the stack behavior. Okay. Next index is 2. Okay. What is the value at index 2? 0, 1, 2. Value is 3. 3 is greater than 4? No. So again it will be popped from the stack. Okay. Next is index is 1. What is the value? 5. So 5 is greater than the current number. Current number is 4. Yes. So I'll stop here. I will not pop this from the stack. And this will be, index will be now 1. Got it? So this is the left array. So in this array, you can just see the array. So in the current index, this index, you can easily check that which is the left index, which value is greater than the current number. So you can just go to the index 1 because the value is now 1. What is the value? 5. And the current value it is 4. So 5 is greater than 4. Yes, it is true. That means -1 means there is no number in the left side which is greater than the current number. And if it's not -1, that means we have some element in the left side which is greater than the current number. Clear? Similar way, I can actually easily find out the right side also, from right to left. You actually iterate from right to left. 2, 5, 3, 1, 4. Right? 2, 5, 3, 1, 4. So now I want to find out the right side. Right? So this will be actually right. Suppose I actually have initialized with suppose n. Now again I will take one stack, or actually I will store the index. Now iterate from right to left. So first of all, our stack is empty, so that means there is no element in the right side which is greater than the current number. So it will actually n. Now before going to the next number, I will store this index 0, 1, 2, 3. So index will be 4. It will be stored into the stack. Got it? Next number I'll come to this 1. Okay. So 1. So what is the actually index present in the stack? That actually 4. So at the index 4, what is the value? Value is also 4. Correct? And what is the current number? Current number is 1. So is 4 greater than 1? Yes. So this is one possible answer because we have some element in the right side which is greater than the current number. So in the right array, it will actually overwrite with index 4. That means we have some element in the right side or the index 4 which is greater than the current number. Got it? So before going to the next number 3, I will store the index. Index it is actually 3. Okay. So now come to this index 2 and the number is 3. Okay. So what is the top index present in the stack? That is actually 3. Now 3 means what is the value? Value here also it is 3. Okay. And current value is 3. And what is the value present in the stack? That is actually 1. Index 3 value is 1. 3 is less, means 1 is greater than 3. No. So it will be not a possible answer. So I'll pop this from the stack. Got it? Next index is value actually I have 4. So index 4, what is the value actually I have? That is actually 4. So 4 is greater than 3. Yes. So this is one index 4. Or actually our value, current value is greater than the current, which value is greater than the current number. So it will actually modified with index 4. Got it? So before going to the next number, I actually identify, I have to actually store this into the stack. So the index will store as 2. Clear? Next, I will come to this index 1 and value is 5. So value is 5, okay. And what is the stack top value? It is 2, index 2. And at the index 2, what is the value? 3. 3 is greater than 5? No. So again, it will be popped from the stack. Got it? Next index is 4. So 4 at the index 4, what is the value actually I have? That actually 4. Right? Index 4 actually I have value is 4. And the current value is 5. Is it 4 is greater than 5? No. So this will be also popped from the stack. Right? Now stack is empty. That means there is no element in the right side which is greater than the current number. You can also visualize from the test case also. Like for 5, is there any element in the right side which is greater than 5? No. So again it will be now n. It will not be modified to any other way. Okay. Now before go to the next index, I have to store this. This will be now 1. Next come to this index 0. Value is 2. Okay. And what is the top index is 1. And what is the value? 5. Is 5 greater than 2? 5 means that in the stack, from the stack, and 2 is the current number. Is 5 greater than 2? Yes. So this means that we actually have some element in the right side which is greater than the current number. So it will be replaced with 1. So final right array will look like it will be 1 n 4 4 n. Okay. So this is actually the right. And for the left, it will be -1 -1 -1 -1 -1 1 2 1. Okay. Now what actually I have to check how many different bowl actually I can create bowl, right? So first of all, I'll come to this index 0. Index 0, currently actually I have index 0. So what actually I have to check that it will create a bowl or not. I have to identify that is there any number in the left side and the right side which is greater than the current number. So how do I check that? Both should be in the left side, it should not be -1, in the right side it should not be n, right? So that's why I'll check that okay, this is 1. That means we have some element in the right side which is greater than the current number. It's okay. But we have to, this should satisfy in the both side, in the left and right, both, right? So that's why I will also have to check that from the left side also. This is -1. That means we do not have any in the left side which is greater than the current number. So that's why it can't actually create a bowl. Next come to this index 1. So I'll check that it can be part of a bowl. So what is the condition for that? It should actually have some element in the left side and right side which is greater than the current number. So here you can see right side it is value is n. That means there is no number in the right side which is greater than the current number, right? So we can't actually create a ball. So go to the next number. Index 2. So what is the value here actually? It is 4. Okay. So that means this is not equal to n. That means we have some element in the right side. Means at the index 4, we actually have one element which is greater than the current number. Right? So okay, in the right side I found that. But from the left side also it should be true. Okay, left side it is actually 1. So that means both sides actually I have some element which is greater than the current number. So this is one possible answer, right? So at the index 2, I can actually create one pole. Now, next index, come to this index 3. So the right side, is there a number in the right side which is greater than the current number? Yes, index 4. Value 4 means in the index 4 actually I have in the input string, in the input array, in the index 4, I have some element which is greater than the current number. Right? In the right side I got. But from the left side also it should be true. Left side also it is not -1. It is 2. That means we have some element in the left side also which is greater than the current number. So both sides it is actually we have some element which is greater than this. So this is one possible in new ball, right? Okay. Next is come to this index. This is actually n. In the right side, n means in the right side array, n means that there is no number in the right side of the current index which is greater than the current number. So that means literally our answer will be there will be no new ball. So our answer will be ultimately 2, 1 ball for this and 1 ball for this index. This is index 2 and index 3. At the index 2 index I can actually create a new ball. So our answer will be 2. Got it? I hope this is clear. You can actually, if you don't know about the monotonic stack, you can know about that. Then actually it will be easy to understand how actually using the monotonic stack here. Got it? Now go to the code. So first of all check what is the input array length. That is n nums of size. Okay, and I actually need two array. One is for the left side, one for the right side. So here we have created a new vector of size n initialized with -1. -1 means to identify that it is actually modified or not. -1 indicates that there is no number in the left side. Okay, and we need actually one stack to store as a to use this as a monotonic stack. Now I will iterate the input array from left to right to find the is there any number present in the left side which is greater than the current number or not, right? So it will be I is 0 to I less than n I plus plus. Okay, so what is your target? Target is to we have to find any in the stack is there any index which is greater than the current number. So if it is smaller than the current number, so I'll pop this from the stack, right? So if our stack is not empty, that means we have some index in the stack, and that index value is nums of stack top, whatever actually index actually it is present, which is less than the current number. That means this will not be our answer. So I'll pop this from the stack. Okay. So it will be continue until actual stack is empty or we got actually some number which is greater than the current number. So I'll check that if your stack is not empty, that means we have some element which is greater than the current number. That means this condition actually it is false. Stack is not empty means this is end condition. So second condition is false. So that time actually I will store the index left of I for the current number I will store whatever the index actually present in the stack top. And before going to the next number, I will store the current index into the stack. Stack dot push the current index is I. Got it? Okay, so now what is left to do? So after this for loop in the left array vector, I can actually easily identify that any index I is there any number in the left side which is greater than the current number or not. Right? I can easily identify that big of one time. Now before going to the next number, to identify that is there any number in the right side also which is greater than the current number or not. So for that I actually here I have used one stack only. You can actually use two stack also for the right side also. So to optimize that memory optimize it, I actually just clear the stack, whatever the stack actually it may be possible that we have some element in the stack. So I'll just clear that before going to the next calculation. So for the right side also I create a new vector of right and size will be n and initialized with n. Okay. Now for the right side, Or actually I will traverse from right to left to identify that is there any number in the right side or not, right? So that's why I am traversing from I is equal to n minus 1 to I greater than equals to 0, I minus minus. Got it? From right to left, because we have to identify the right side, right? So that's why process the right side first, then process the current index. So similar condition here also, if your stack is not empty and whatever the index is present in the stack, if that value is less than the current number, so that means this is not a or one possible answer, so I'll pop this from the stack. Got it? So it will continue until our stack is empty or we do not found any uh, index which is greater than the current number. So if our stack is not empty, that means we have some element in the array in the right side which is greater than the current number. So I'll store this array. So right of I, it will store the whatever the index is present in the stack top. Got it? Else I will not modify. It will be else means our stack is empty. That means it will be actually the index value at the index I. The value will be n because it is initialized to with n. Right? So before going to the next number, I will store the current index into the stack. Got it? So after this for loop from the right array, from this right array, I can easily say that at any index I, is there any number in the right side which is greater than the current number or not, right? So after this line number 32, I actually have checked. I can actually easily say that is there at any index I, is there any number in the left side which is greater than the current number or not from the left array, and from the right array I can easily say that is there any number in the right side or not which is greater than the current number or not, right? So I have written the number of bool actually I can create. So it will be actually integer type. Sorry, here is the return type is long. So I actually initialize with long. Answer is initialized with 0. Now for each index I is 0 to n minus 1. I'll check that for each index I can create a new bool or not. So what is the condition to create a bool? Condition is that in the left side also we have some element which is greater than the current number. In the right side also we have some element which is greater than the current number. So left of current index I, if it is not equal to minus 1, that means we have some element in the left side which is greater than the current number. Similar from the right array also, I'll check that if it is not equal to minus 1, sorry, not equal to n, from the right array actually I will initialize with n. So if it is not equal to n, that means we have some element in the right side also which is greater than the current number. So that time I will actually increase the answer frequency, means create a new bool. Okay. So this is clear. Actually I have to check the both condition, it should be true. Got it? After this for loop, I have checked all the index section, and I will check that it can actually create a new bool or not, right? So I will return the whatever the count actually I have answer variable. So return that. So what is the time velocity for this approach? So you can see here that actually I have used a for loop here. So this will be big of n because I am iterating the input array from 0 to n minus 1. So it will be big of n. Next here also it will be just clearing the stack, so it will be again big of n. Next for the right side also I am iterating the whole input array again from right to left, it will be again big of n. And after this, to check that each any index it can create a new bool or not, so this will be again big of n. You can just see that just iterating for loop from 0 to n minus 1. So ultimately here the time will be big of n. Alright, got it? So I've shared this code in the description also, you can check that. And before closing this session, if any doubt, any suggestion, any comment, you will comment on that. Okay, so bye bye.